If humanity vanished tonight, 1,000,000 years from now, would the earth remember us? Or has it happened before, a civilization erased so completely that even its ghosts turned to dust? Beneath the hum of modern cities, beneath the endless pulse of data and light, the earth keeps a silence older than history. Every heartbeat of civilization, every tower, every dream pressed against a world that has seen everything and remembers almost nothing. In the deep ocean of time, even memory drowns. What if this has all happened before? What if somewhere deep within the planet's layered bones lies the trace of another world? Not alien, not distant, but ours. Forests melt into deserts. Mountains rise, crumble, and vanish beneath seas. The continents themselves drift like restless ghosts. Millions of years flicker by in seconds, and humanity's story appears only as a spark, a flash of fire against eternity. For 4.5 billion years, the earth has turned. But our entire species, our cities, our science, our art, has existed for less than the final blink. If intelligence rose once before, would we even know? The idea sounds like myth, a forbidden thought once buried beside legends of Atlantis and golden ages lost to flood and fire. But in 2018, two scientists, NASA climatologist Gavin Schmidt and astrophysicist Adam Frank, asked the question not as fiction, but as physics. Their proposal carried an unassuming name, the Silurian hypothesis. It asked, if an industrial civilization had existed on Earth millions of years ago, would its traces still be detectable today? The answer, whispered by the rocks themselves, would change everything. Because the truth is, the Earth forgets. The question began not in fantasy, but in the cool precision of data, in the long, slow archives of ice, mud, and stone. Gavin Schmidt, studying the scars of human industry in the atmosphere, realized that Earth's climate preserves faint chemical echoes of our civilization. Carbon isotopes, synthetic molecules, radioactive residues, these are our fossils, etched not in bone but in chemistry. But what if the same clues appeared in epochs far older than humanity, buried in the Eocene? The Cretaceous? The Silurian seas, could there have been others? The Silurian hypothesis took its name from a doctor who referenced a race of intelligent reptiles who ruled Earth before mammals. But the scientists were dead serious. They asked, could geology itself hold the fingerprints of forgotten intelligence, burned carbon, altered isotopes, industrial waste, the invisible ashes of an earlier Anthropocene? The notion struck at the foundations of human history. Because if we could not detect our own civilization millions of years from now, how could we claim to know there were none before us? For centuries, humanity's story was measured not in chemistry, but in myth. Ancient texts from Egypt to Mesopotamia spoke of prior ages, of gods walking the earth, of floods sent to erase what came before. Plato's Atlantis, the Mayan cycles, Hindu cosmologies, Uga's epochs of rise and collapse, repeated eternally. But science brushed these aside as allegory, not evidence. Then geology arrived, the first discipline to give time a depth beyond imagination. Charles Lyell, in the 1830s, revealed that landscapes were not shaped by divine events, but by the patient, grinding work of time. Darwin, following Lyell's insight, saw life as a slow bloom unfolding over eons. And yet, in the same framework that birthed evolution, a new ghost appeared. If the earth was so ancient, and time so vast, what else might have lived and thought and perished long before us? Carl Sagan once asked a version of this same question. He spoke of archaeology on geological timescales, of the possibility that the past might hide entire chapters of civilization, written not in stone tablets, but in isotopic whispers. The question haunted the margins of science, too strange to dismiss, too possible to ignore. The deeper scientists looked, the more they saw the Earth's ruthless efficiency in forgetting. Deserts that were once ocean floors, mountains that were once coral reefs. Every few 100 million years, continents collide, subduct, and vanish, carrying with them all the memory of what once lived upon them. Even fossils, those rare survivors of deep time, form only in the most fragile of conditions. The Earth, for all its patience, is not an archivist. It is a recycler. Every record, every monument, every digital breath of human civilization is being slowly erased already, swallowed by wind, rain, and tectonic hunger. If we vanish tonight, within 10,000 years our cities would crumble. In 1,000,000, their skeletons would sink beneath soil. In 100 million years, nothing would remain but a chemical shadow, a faint layer of carbon, a trace of plastic dust, a signature in sediment that no creature might ever decipher. This is the paradox. The more advanced a civilization becomes, the faster it risks being forgotten. In laboratories and observatories, scientists began to frame this idea not as speculation, but as experiment. If Earth's rocks carry the echoes of life from ancient bacteria to dinosaurs, then perhaps they also carry the echoes of thought. Researchers began to search for patterns, unexplained isotopic shifts, abrupt warming events, rapid extinctions, moments when Earth's balance changed too quickly, as if by some internal hand. One event, the Paleocene thermal maximum, stood out. 56 million years ago, the planet's temperature spiked abruptly. Carbon dioxide flooded the atmosphere. Oceans acidified. Species vanished. It looked disturbingly familiar, a mirror of what's happening now. Scientists attributed it to volcanic eruptions, methane release, natural cycles. But could it also be, even faintly, a buried memory of industry, erased by time's tide? The Silurian hypothesis didn't claim it was. It only asked, how would we know if it were? That question cracked open the boundary between science and philosophy, because, in the end, this mystery isn't really about them, the hypothetical ancients. It's about us. It forces civilization to look into the mirror of time and ask, what is permanence? What is legacy? What survives the slow violence of the planet that made us? Every epoch, every species, every tower of ambition eventually becomes geology. The fossils of fish become limestone. The bones of mammals become dust. And perhaps, once before, the dreams of another thinking world became nothing more than an unexplained layer in stone. Science moves forward, cautious and skeptical. No proof has been found. But for the first time, the question is not myth, it's measurable. The search for the past has become a test of the present, of whether our own civilization will leave behind a trace at all. Because maybe, in the eyes of eternity, even intelligence is temporary. Maybe every world forgets the ones who came before, and somewhere, deep beneath the ancient crust of this planet, the Earth itself may still be whispering the same question back. How many times must I remember before I forget again? The Earth has no memory, only motion. Every stone that seems eternal is, in truth, moving, dissolving, becoming something else. To live on this planet is to stand upon a page that is constantly being rewritten. And beneath the script of history, the older sentences are being erased. Mountains crumble into dust. Rivers carve the faces of countenance like patient blades. The sea swallows coastlines, then withdraws, leaving ghosts of coral and sand where once there were cities. Even the continents themselves, drift rising, colliding, vanishing beneath one another like tectonic ghosts. The earth devours its own evidence. And that, perhaps, is its greatest secret. When scientists first began to grasp this truth, it struck like revelation and horror. The ground beneath their feet, once thought solid and eternal, was alive. Not alive as in breathing, but alive in motion. A planet-sized organism whose bones grind and shift across molten currents, reshaping itself over hundreds of millions of years. This is plate tectonics, the slow ballet of continents drifting atop the mantle. Every few 100 million years, the surface of the world is recycled. Ocean floors are swallowed into the deep mantle. Mountains, once towering over seas, are ground into silt and spread across the ocean bed. Even the most ancient rocks we know are exceptions, survivors of a process that erases almost everything. If the earth were a library, it would be one that burns and rebuilds itself every age, and each new book would be written on the ashes of the last, the fossil record. Our deepest window into life's past is not a chronicle, but a lottery. Most creatures never fossilize. Their bones are consumed, dissolved, scattered, turned to dust long before they can leave a trace. Only in the rarest, most merciful moments, death meets the right chemistry and the right silence. Time pours long enough for a fossil to form. Paleontologists estimate that less than 0.1% of all species that ever lived are preserved in stone. And of those, only a fraction have been discovered. The story of life we read in textbooks is not the whole book, it's a few surviving sentences from an epic billions of years long. If biology is that fragile, imagine technology. Silicon, steel, and glass, our proudest creations, are the most temporary things of all. Scientists have modeled what would happen if humanity disappeared tonight. 10,000 years from now, the forests would return. The jungles would swallow our monuments. The sea would rise through our cities. And the wind would sand our towers to nothing. Even the bones of skyscrapers, reinforced concrete and iron would decay, their metals eaten by the chemistry of soil and time. 1,000,000 years later, not a single recognizable structure would remain. Perhaps a few traces, plastic particles in ocean sediments, strange isotopic patterns in the soil, faint layers of synthetic molecules buried in the rock. But even those signatures, given enough time, would blend into the planet's natural background, and 100 million years from now, the continents themselves would be somewhere else. New mountains, new oceans, new atmospheres. The traces of humanity of every empire, every idea gone as though they never were. This is not imagination. It is geophysics. The same processes that built the world also erase it. Even the bones of the dinosaurs, our most famous fossils, are rare survivors of a near-total annihilation of evidence. And their bones endure only because they were buried fast, in the right place, in the right way before the earth could recycle them too. If entire epochs of life can vanish almost without a whisper, what chance would a civilization have? The scientists of the Silurian hypothesis understood this dread intimately. When Gavin Schmidt and Adam Frank proposed the question, How would we know if another industrial civilization existed before us? They realized the answer might be simple and terrifying. We wouldn't. Even a world as advanced as ours would fade from the rock record almost completely. In 100 million years, there might be nothing left but a few ambiguous signals, a carbon isotope anomaly resembling fossil fuel burning, a thin layer of plastics chemically transformed by radiation, and a subtle shift in sediment chemistry indicating a sudden, unnatural warming of the planet. To future geologists, if any existed, it might look like a natural event, a volcanic pulse, a methane burst, a fleeting disturbance in the endless breath of the earth. Our civilization, our towers, our algorithms, our art would be reduced to geochemical noise. There is a term scientists use for this. New epoch, the Anthropocene, the age of humans. It is meant to mark the moment when civilization became a planetary force, altering climate, geology, and biology. But the more researchers study it, the more fragile it seems. How long does an epoch last if its evidence fades in a blink? Plastics are most enduring. Invention may last hundreds of thousands of years in some form, yet even they degrade into molecular dust. Concrete dissolves, steel rusts, cities crumble, and when the tectonic plates swallow the seafloor, even that dust will vanish into magma. Only the subtlest chemical fingerprints might remain. Carbon-12 enriched from fossil fuels, nitrogen spikes from industrial fertilizers, a faint radioactive shimmer from atomic testing, perhaps the most durable mark we will ever leave behind. That will be our monument, not the pyramids, not the satellites orbiting Earth, but a thin, nearly invisible line in the rock, buried beneath millions of years of silence. This realization stunned the scientific world, not because it proved an ancient civilization existed, but because it revealed the scale of what we could lose. Humanity's pride in its permanence, its cities, its memory, its dominion suddenly seemed absurd. The Earth is a destroyer of evidence, a perfect eraser. Even as humanity builds toward the stars, the ground beneath us is already reclaiming our story. The continents shift imperceptibly, grinding our ruins into sand. Every monument, every data server, every word carved in stone will in time become dust to the earth. 1,000,000 years is nothing. To us, it is everything. And so the scientists looked again at the silence of the past, at the long, blank stretches of geological time where no trace of intelligence remains, and began to wonder, maybe that silence is not proof that there were none before us. Maybe it's simply what time does to memory. The fossils of civilizations, like the fossils of life, are destined to fade. The earth remembers in whispers, not in monuments, and those whispers, scattered across the layers of stone and sediment, are all that remain of any who dared to think they would last forever, because in the end, the planet forgets, and the silence beneath our feet is not emptiness, it is the sound of eternity turning the page. Asterisk, there is a difference between looking for ruins and listening for ghosts. By the time humanity learned how completely Earth erases its past, the hunt for evidence had to change. If no monument could survive, if no skeleton of a city could endure the slow crush of geological time, then the search for lost civilizations had to begin in the invisible, in the chemistry of the planet itself. This is where the story turns from archaeology to astrobiology, from shovels to satellites. In 2018, two scientists, Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and Adam Frank, astrophysicist at the University of Rochester began to ask a question that trembled between science and philosophy. If another civilization had once risen upon this world, how would the planet remember it? They called it the Silurian hypothesis, and their answer was radical in its simplicity. Forget the artifacts. Forget the bones. Search instead for industrial fingerprints, because even if time erases the shape of a city, it cannot entirely erase the chemistry of its breath. Every civilization leaves an atmospheric echo. To burn fossil fuels is to rewrite the sky, to alter the balance of carbon isotopes that flow through air, ocean, and stone. Our modern signature is unmistakable: a sharp, rapid enrichment of carbon-12 relative to carbon-13 spread evenly across the globe. It is the geochemical voice of industry, a planet's respiration, gone shallow and fevered. Schmidt and Frank realized that such an isotopic pattern would not vanish overnight. Even millions of years later, it could still be seen in deep ocean sediments, in the frozen archives of rock, like a faint fingerprint pressed into time. If we can detect our own chemical disturbance today, then the same method could be turned backward. The past, after all, is full of anomalies, strange pulses in climate and chemistry that no one can fully explain. One event in particular draws the eye of every paleoclimatologist: the Paleocene thermal maximum, or PETM. It happened roughly 56 million years ago, long after the dinosaurs, long before humanity. Within just a few thousand years, a heartbeat in geological time, Earth's temperature surged by 5 to 8 degrees Celsius. Carbon flooded the atmosphere. Oceans turned acidic. The planet's ecosystems convulsed. And then, slowly, over 200,000 years, the fever broke. In the strata from that period lies a thin, dark layer, a chemical scar. It shows exactly the same kind of carbon isotope anomaly we see today, one that could be produced by the massive combustion of organic carbon. The leading explanations are natural: volcanic eruptions, methane clathrates, a destabilized carbon cycle. But Schmidt and Frank asked the question that others avoided: could an earlier civilization, non-human, pre-human, have triggered a similar pulse? Could the PETM be not merely a natural catastrophe, but a forgotten Anthropocene? No scientist claimed it was, but the act of asking changed the field. It reframed humanity's own impact as part of a deeper cosmic puzzle. How civilizations, if they rise, leave their mark upon a planet, and how quickly that mark fades. The search expanded beyond carbon. If another species had mastered industry, it might have produced synthetic molecules, things nature never makes on its own. Polychlorinated biphenyls, or PCBs, are one such example. Durable, toxic compounds that can persist in sediments for millions of years. Others include plastics, which break down but never disappear, and which leave unmistakable spectral fingerprints. Then there are the radioactive isotopes, born from nuclear fission, and capable of surviving, in trace amounts, for hundreds of millennia. These, too, could become part of the geological record, an atomic signature of intelligence. Each of these markers tells a story of entropy and persistence. They do not announce civilization in clear words. They whisper in riddles: a spike in isotopes, a trace of synthetic dust, a thin, unnatural film between epochs. In science, such riddles are called anomalies, and the Earth is full of them, in ocean cores and polar ice. Researchers have found layers of abrupt change, rapid warming, sudden extinctions, unaccountable chemical surges. Most have natural explanations. Some do not. Each one becomes a mirror held up to our own age, because what the Silurian hypothesis truly revealed was not proof of past intelligence, but the fragility of present intelligence. By searching for ancient civilizations, scientists discovered how invisible their own might one day become. Every test of the hypothesis is also a rehearsal for our own disappearance. If we cannot see them, perhaps others will not see us. If we struggle to find their fingerprints, perhaps ours too will fade into the same geological haze. It is not just an archaeological search. It is a time experiment, an examination of how visible we are to the future. To understand what that means, picture Earth in the far future. 10 million years from now, continents have shifted. The Himalayas have crumbled into plains. The Amazon has become desert. Where our cities once stood, layers of sediment build quietly, year upon year, tide upon tide. Deep beneath them, in a layer of stone scarcely thicker than a finger, lies a pattern of chemical disturbance. Traces of plastic polymers turned to hydrocarbons. A bloom of carbon-12 in the carbonate record. A dusting of radionuclides from long-forgotten reactors. No monuments remain. No bones of steel or glass. Only a signature brief, sharp, and then gone to whoever might study it. If anyone ever does, it could mean anything. A methane surge. A volcanic convulsion. A natural hiccup in a planet's long respiration. Nothing about it would whisper civilization. Nothing would say intelligence was here. And yet, perhaps, that is the point. The Silurian hypothesis was never truly about finding others. It was about learning to see the planet as the true archive of consciousness, an archive that forgets, but never entirely. Every civilization, by living, writes into its environment. Every world that hosts life becomes a storyteller, etching its own rise and fall into the chemistry of its crust. If life elsewhere, in the cosmos, follows the same laws, if other worlds, too, breathe and burn and forget, then maybe all civilizations are fossils in waiting. Not monuments of stone, but alterations in equilibrium. Not ruins, but patterns. The soft signature of thought upon matter. And so scientists keep searching, not with shovels, but with spectrometers and satellites. They peer into Earth's strata and into the atmospheres of distant exoplanets, looking for the same kinds of fingerprints. A planet out of balance, a sky reshaped by industry, a chemical story that cannot be told by geology alone. Because to find another civilization's echo, even one erased by time, would be to glimpse a truth larger than humanity itself. That consciousness is not unique, but cyclical. That every intelligence eventually meets the same horizon of entropy. That every light, no matter how bright, fades into the stone. And as scientists trace those faint, silent anomalies across the eons, they begin to hear a deeper resonance. One that belongs not to ancient civilizations, but to the living one now. The search for the forgotten has become a mirror. In studying the planet's memory, we are, perhaps, measuring our own. And the question that remains quiet, endless, unanswerable, is no longer were they here. It is, will we be remembered? Asterisk beneath every stone lies another history. Every mountain is a page rewritten. Every fossil, every grain of sediment, an erased sentence in Earth's endless book. But some pages resist erasure. Some retain a whisper of what once was. And it is in those quiet fractures those geological scars, that the mystery deepens. For decades, the search for forgotten civilizations lived in chemistry and isotopes, in invisible fingerprints and spectral tracers. But then came a different kind of question. If civilization truly rose before humanity, could anything of it physically remain? Could a fragment, a pattern, a structure endure the crushing silence of geological time? The first clues were not alien or impossible, merely strange. Across Scotland, Ireland, and parts of France stand the vitrified forts, ancient stone walls fused by intense heat. To the eye, they seem melted, as if once turned briefly into glass. Most date to the Iron Age, human in origin, but their mechanism remains contested. What could have produced heat high enough to liquefy granite, yet leave the wall intact? Some say warfare wooden scaffolds burned until the walls glazed. Others suspect lightning strikes or accidental fires made catastrophic by mineral composition. But the image persists, of stone rendered molten, an echo of technology beyond its supposed age. It is a reminder that even the simplest ruins can mislead the future. A natural process mistaken for artifice, or artifice mistaken for the natural. That is the heart of the dilemma: temporal bias. Human civilization occupies less than 0.0001% of Earth's timeline. To imagine that the geological record could clearly separate natural from artificial across hundreds of millions of years may be arrogance disguised as reason. We assume that intelligence must build towers, forge metals, sculpt geometry. But what if it did none of these things? What if its expression of culture, its equivalent of art, of science, lay in mediums we no longer recognize? A civilization could rise in the ocean depths, using bioluminescence as architecture, or evolve within subterranean networks, their entire existence confined to the lithosphere. Would the fossil record even notice? This is not science fiction. It is humility, the recognition that our definition of civilization is built from the mirror of ourselves. To search for others beneath our feet is to admit that we may not know what to look for. Still, there are scars in the stone that refuse to be easily dismissed. Mass, die-offs, scattered through time, sharp, catastrophic, global. The Ordovician extinction, the Permian collapse, the Triassic-Jurassic transition, each marked by chemical chaos, spikes in carbon and sulfur, traces of heavy metals, abrupt warming and cooling. We call them natural, volcanic outbursts, asteroid impacts, methane releases. But in truth, many remain unexplained. In deep ocean cores, researchers have found isotopic outliers, deposits of elements like iridium, plutonium, and uranium-236, where none should be. Sometimes these are traced to meteorites or nuclear testing in recent centuries. But some layers predate humanity altogether, lying buried in epochs where no known process could have produced them. Are there errors in measurement, natural geochemical coincidences, or remnants of processes once intelligent, now indistinguishable from geology itself? Science does not claim certainty. It claims curiosity, and curiosity, when faced with the unknown, is indistinguishable from reverence. To understand what could survive, scientists turned to simulation. They modeled the decay of modern civilization through deep time. After 10,000 years, cities crumble. After 1 million, erosion buries all trace. After 100 million, continents have drifted, seas have risen and fallen, and all that remains of human existence are thin, dark lines of sediment, chemically altered, yet mute. If such a horizon could hide us, what might already lie hidden within it? Consider the Mariana Trench, 11 kilometers below the surface of the Pacific. There, sediments fall like snow, slow and unending. Each century adds mere millimeters, but over millions of years, the weight of time becomes unbearable. If anything once lay upon that ancient seabed, a structure, a machine, a monument, it now rests entombed beneath kilometers of pressure and stone. And to reach it would mean drilling deeper than humanity ever has. Into a world where light has never touched. The same holds true for the cratons, the planet's oldest rock cores, buried under younger crust-like, forgotten hearts. Some date back 3.5 billion years, yet have never been fully excavated. Whatever secrets they contain are locked within the compression of eons. In such a place, even steel would flow like wax. Even glass would turn to sand. Geologists have begun to describe Earth as a palimpsest, a manuscript rewritten endlessly by time. Each epoch overlays the last, scraping away words, erasing histories, leaving only faint impressions of what once was. Mountains are recycled text. Oceans are ink. Volcanoes are the hand that writes anew. To read this manuscript is to acknowledge its cruelty. It remembers only what it must in its pages. Humanity's story is barely a comma. And yet, like any good editor, the planet leaves traces of revision, small inconsistencies, odd survivals, grains of glass in ancient strata, metals alloyed in unnatural ratios, microscopic spheres of fused silica scattered through layers predating known human fire. Each anomaly has an explanation, almost, but the pattern, the recurrence of inexplicable heat, of transient metal traces, of sudden global chemical shifts, begins to whisper a question that refuses to die. Could civilization too be a cyclical process? Could Earth have written the same story more than once, only to erase it again and again? Science resists romance. It demands evidence, not poetry. And yet, the deeper researchers peer into the stone, the more the two become indistinguishable. To interpret a billion-year-old anomaly requires imagination. To confront the possibility of forgotten intelligence requires restraint. But both demand awe, the willingness to look into deep time and admit that we are not its measure, only its most recent translation. If another civilization once thrived here, perhaps its legacy is not found in artifacts at all, but in the habits of the planet itself. In every mass extinction, every chemical convulsion, every inexplicable warming, each could be the aftermath of a rise and fall, not of continents, but of consciousness. And so the search continues, beneath deserts and oceans, within the slow pulse of Earth's mantle. Satellites map magnetic anomalies. Drills extract cores from kilometers below. Supercomputers reconstruct the world's vanished coastlines. What they find is silence, yet not an empty one. A silence that feels dense, deliberate, as if holding its breath. Perhaps that is the true condition of a remembering planet. Not revelation, but withheld memory. A world that keeps its deepest truths buried, not out of malice, but out of entropy, somewhere. Far below the reach of light and time, beneath continents that were once seas and seas that were once skies. The story of another civilization, if it ever existed, may still rest intact, pressed flat, fused, dreaming in the dark. And perhaps the greatest mystery is not what lies beneath, but how long it will take before we, too, become another shadow beneath the stones. Time is not a river. It is a tide, rising, receding, erasing. Every civilization, no matter how radiant, eventually dissolves beneath its pull. And as scientists began to peer deeper into the Earth's past, they uncovered a truth far more unsettling than absence. The universe does not merely hide evidence, it consumes it. The question that began as speculation, were we the first, was transforming into something more profound. What if it is not that no one came before, but that time itself is engineered to forget? In this realization, the search for ancient intelligence became a mirror, reflecting not the mystery of others, but the fragility of our own story. Earth is a master of erasure. It rebuilds itself with exquisite cruelty. Continents drift, subduct, and drown. Mountains rise and decay. Entire oceans vanish into stone. Every 100 million years, the surface of the planet remakes itself almost completely. To imagine that any civilization, human or otherwise, could withstand such cycles is to underestimate the brutality of geological time. The scientists turned to numbers. If a city were left to rot beneath today's skies, how long would it last? After 100 years, the steel skeletons would rust, glass would splinter, and nature would reclaim the streets. After 10,000 years, only the faintest architectural ghosts would remain, buried under soil, silt, or sea. After 1 million years, plate tectonics would twist and grind what remains into anonymous dust. After 100 million, the continents themselves would have moved, our monuments transformed into quartz veins, our satellites into minerals, our art into the chemistry of forgotten rock. At that scale, even the memory of memory disappears. The fossil record does not stretch like a line, it flickers, brief and uncertain. Less than 1 in a billion species ever fewer still leave artifacts, and those that do must survive the twin predators of entropy and time, forces that spare nothing, not even light. In physics, this dissolution is not metaphor, it is law. Entropy, the measure of disorder, ensures that every structure, physical, informational, or cultural trends toward decay. Mountains erode. Stars collapse. Even data itself is subject to entropy. Digital records, magnetic imprints, and even atomic alignments are all temporary arrangements within a universe destined to scatter them. Information can persist, but not unbroken. It diffuses, fragments, hides in noise. The late physicist John Archibald Wheeler once proposed that the universe is fundamentally composed of it from bit, that reality itself is built from information. If that is true, then time is not just a destroyer, it is a Every moment, the cosmos edits its own script, converting memory into oblivion. What remains of a civilization, then, is not its monuments, but the faint statistical residues of its existence, isotopic whispers in the language of decay in this light. The Anthropocene humanity's own geological chapter takes on a chilling perspective. Imagine humanity vanishing tonight. What would tomorrow remember? After a century, nature would reclaim the cities. The hum of electricity would fade. The stars would shine brighter over darkened skylines. After 10,000 years, forests would swallow the monuments, and the air would clear of carbon haze. Only plastic and a thin chemical trace in the soil would betray that we had ever been. After 1 million years, tectonic drift would distort our coastlines, erasing the outlines of nations. The Eiffel Tower, the pyramids, the Great Wall, all rendered into mineral ghosts, Our satellites would have fallen, burned to vapor in the upper atmosphere. The last vestiges of civilization would exist only as trace elements, caught in ice or clay. After 100 million years, even those traces would fade. The continents would have shifted, subducted, reborn. Our world would no longer know where our seas once were. Humanity would exist only as a thin, unremarkable layer of altered sediment, indistinguishable from any other fluctuation in the long symphony of Earth to the distant future. We would not be a civilization. We would be a brief chemical event. Scientists began to realize that the question, "Were we the first?" hides another, quieter one. How visible are we to time itself? Every skyscraper, every encoded drive, every piece of music is a defiance of entropy, but only temporarily. We think our legacy is architecture, art, or technology. But from the planet's perspective, our true legacy is change in composition. We leave not statues, but isotopes. Not cathedrals, but carbon. When Gavin Schmidt and Adam Frank proposed the Silurian hypothesis, they did so not merely to ask if others came before us, but to measure how we would appear if others came after. Their conclusion was devastating in its simplicity. If a civilization as advanced as ours had existed even 100 million years ago, it would be effectively undetectable today. Not because it was hidden, but because the Earth itself forgot. And so the hunt for predecessors became an act of self-study, a geological meditation on impermanence. Each core sample, each isotopic anomaly, became a mirror showing our own eventual erasure. Our skyscrapers, our satellites, our data, all temporary constellations in a universe that endures by forgetting. There is a haunting paradox here. The more advanced a civilization becomes, the more delicate its evidence. The more it learns to manipulate matter, the finer and more ephemeral its signature becomes. A stone tool might survive 1,000,000 years. A silicon chip, perhaps 1,000. A quantum computer, almost none. In chasing efficiency, we create fragility, progress measured in the art of vanishing. So perhaps invisibility is not the exception, but the rule. Perhaps time's truest intelligence lies not in preservation, but in forgetting. If civilizations rise and fall across epochs, then maybe the universe itself is not a graveyard, but a recycling consciousness, one that turns memory into possibility, the past into the raw material of new beginnings. In the end, time becomes both destroyer and witness. Every erosion, every decay, every quiet collapse is not the end of a story, but the rewriting of one. And as humanity stares into the abyss of its own impermanence, the question of ancient civilizations no longer feels distant or hypothetical. It becomes intimate, personal, inevitable. We were never searching for others. We were learning how to see ourselves as creatures of fleeting light. In an ocean of geological night, the rocks beneath us will forget our names. The stars above us will forget our fires. But perhaps somewhere in the faint hum of carbon, in the isotope signatures of vanished ages, the memory of thought itself lingers, not as words, not as monuments, but as a single, enduring echo that once, for a moment, consciousness burned here, and time mercifully let it fade. Asterisk, there comes a point where science meets imagination, where data runs out and only possibility remains. Here, the Silurian hypothesis transforms from a question of geology into a question of existence itself. If civilizations can vanish so completely that even the planet forgets them, what forms might they have taken? and what laws of nature might have guided both their rise and their silence. The first frontier of speculation lies not among the stars, but beneath the waves. Some scientists have dared to imagine that the first intelligence on Earth might not have walked upon land at all. Consider the cephalopods, octopuses, cuttlefish, squid, creatures of ancient lineage, with nervous systems as complex as small mammals. They are problem solvers, escape artists, tool users, capable of disguise, mimicry, even curiosity. And yet they live brief lives, measured in years, not decades. What if, long before the dinosaurs, a branch of their kind had evolved longer life, cooperative structure, and memory? A civilization of fluid minds, communicating not through sound, but color and light. Architecture built from coral and current. If such a society rose in the deep oceans of the Devonian, how would it? It wouldn't. It would dissolve, erased as completely as the waves that carried it, beneath the crushing weight of epochs. The idea lingers. Perhaps intelligence was not a human invention, but an evolutionary rhythm, emerging, collapsing, re-emerging like the tides themselves. Others look to the age of reptiles. For nearly 200 million years, dinosaurs ruled the Earth, long enough, by far, for intelligence to have had time to bloom. Yet, among their remains, we find no tools, no signs of industry. But what if intelligence took a form unlike our own? What if it evolved not as technology, but as biology? A collective mind and instinctive network spread through ecosystems rather than individuals. A consciousness that left no artifacts, no metal, no fire, only coordination, intention. An invisible will behind the movement of life itself. The fossil record would call it instinct. But perhaps instinct is simply thought that has forgotten itself. In the 1980s, a few speculative biologists proposed a provocative concept, non-anthropocentric, intelligence, minds not bound by tools or language, but by pattern and adaptation. An ecosystem thinking through evolution, reshaping itself from within. Could the planet itself have once been aware, then fallen silent again? Each extinction, each rebirth, a kind of neural pulse in the mind of Earth. Yet the most haunting theory comes from closer to home. What if there were other civilizations, not millions of years ago, but merely hundreds of thousands, before Homo sapiens were alone? We know we shared this planet with other hominids, Neanderthals, Denisovans, Homo erectus, Homo naledi, each intelligent tool using communicative. Could one of them have reached further, built something we now mistake for natural formation? A brief epoch of mastery erased not by time, but by catastrophe or by us. For years, archaeologists have uncovered fragments of mystery, stones worked with precision beyond their expected date, pigments used with intention before recorded art, evidence of fire and craft in layers far older than our species. Most can be explained by evolution's slow march, but some resist easy classification, as if the Earth occasionally remembers. In flickers, that consciousness has walked this path before. Across disciplines, the question of forgotten civilizations touches something deeper, the cyclic nature of intelligence itself. What if consciousness is not a linear ascent, but a recurring phenomenon, a planetary feedback loop that arises whenever conditions permit? A civilization grows, extracts, expands, and in doing so destabilizes the system that birthed it. The biosphere reacts. Balance is restored through collapse. This pattern, if true, would be woven into the planet's own metabolism. intelligence as both symptom and cure, appearing when needed, vanishing when it must. Physicists see echoes of this in entropy itself. The second law of thermodynamics ensures that all systems, physical or social, trend toward disorder. To maintain order, energy must be consumed. Civilizations thrive by transforming energy into structure, but that very process accelerates their decay. The brighter the fire, the shorter the flame. If countless civilizations have risen on countless worlds, perhaps this is their universal law. Intelligence carries the seed of its own entropy. Theoretical physicists and astrobiologists have begun to trace this logic outward, linking Earth's silence to the wider Fermi paradox. If the universe is ancient and vast, where is everyone? Why do we not see the light of others? Perhaps the answer is not that they never were, but that they learned to vanish. Some may have destroyed themselves through excess. Others may have transcended material form entirely, leaving no detectable footprint. Advanced civilizations might eventually converge on a form of existence that consumes no energy, emits no signal. A technological singularity turned inward, collapsing into stillness. From our perspective, such silence looks like absence, but from theirs, it might be equilibrium, a kind of cosmic peace. The late physicist Freeman Dyson once speculated that advanced intelligence could spread its consciousness into the cold fabric of the universe, slowing its thoughts to match the cooling of the cosmos, living in near-eternal contemplation, invisible to our hurried senses. In that light, the quiet of the sky may not be loneliness. It may be patience. Then there are those who look not outward, but within the mathematics of decay. Information theorists like Seth Lloyd and Max Tegmark have proposed that all civilizations face limits set by computation itself, that as systems grow, they generate heat, noise, and instability that eventually drown out their signal. A planetary intelligence may therefore reach a point where its own data collapses under the weight of its complexity, a thermal death of knowledge, echoing the universe's ultimate fate. Others envision self-limiting intelligence, civilizations that recognize the danger of progress and deliberately retreat from visibility. Perhaps they encoded themselves into the genomes of life, or the quantum fluctuations of matter. Perhaps intelligence does not die, it hides, waiting for the next age to rediscover it. Each hypothesis, biological, geological, physical, returns to one chilling echo. If it happened before, it could happen again. We are not immune to the same cycles we theorize. Our machines devour the planet's memory faster than any volcano or asteroid. Our data floats fragilely in magnetic lattice that will one day dissolve into dust, and our brief Anthropocene, for all its brilliance, may already be writing itself into oblivion. The search for forgotten civilizations has become something else, a reflection on our own mortality as a species. It is no longer about finding evidence of others, but about understanding the inevitability of loss. Perhaps the reason we see no ruins of ancient intelligence is because ruin is the natural end of intelligence itself. And yet, buried within that despair is something profoundly human, a quiet defiance. For every law of entropy, there is also memory. For every cycle of collapse, a spark of rediscovery. The universe forgets, yes, but it also remembers, not through permanence, but through recurrence. Somewhere, deep in the bones of the earth or in the silent data of the stars, the memory of thought endures, perhaps not as words or monuments, but as a rhythm, a pulse that beats through time. whispering across ages and forms. You have been here before. You will be here again, asterisk. There is a new kind of listening taking place, not with ears, but with instruments that can hear the slowest voices in the universe, the hum of isotopes, the whisper of buried sediments, the faint resonance of ancient air trapped in ice for millions of years. Science, once content to measure the present, has turned backward to listen to Earth as if it were a memory device, a palimpsest of civilizations, climates, and forgotten moments. Each layer of rock, each grain of dust, becomes part of a planetary archive. And somewhere within that archive, perhaps, the ghost of an earlier intelligence waits to be heard. In a laboratory in New York, climate scientist Gavin Schmidt and his colleagues still ponder the implications of the Silurian hypothesis. It began as an intellectual exercise, a question asked half in jest, half in awe. If another civilization had existed on Earth millions of years ago, how would we know? The answer, it turns out, is far more complicated than expected. Artifacts, cities, and bones vanish quickly, but chemistry remembers. Carbon isotopes shift subtly when a planet burns fossil fuels. Synthetic molecules, plastics, refrigerants, industrial compounds leave fingerprints in soil and ice. And radioactive isotopes, the byproducts of nuclear reactions, can linger for tens of millions of years. So scientists have begun to search for non-biological anomalies, patterns in sediment that do not fit nature's rhythm. It is less archaeology than forensic geology, a study of the planet's unconscious. At the edges of Antarctica, researchers drill down through 3 kilometers of ice, retrieving cores older than human civilization itself. Each meter of ice is a chapter of atmospheric history. Tiny bubbles, trapped during ancient summers and winters, hold air unbreathed for millennia. When examined with mass spectrometry, those bubbles tell stories of volcanic winters, solar shifts, industrial emissions. The precision is staggering. The ratio of carbon-12 to carbon-13, the slight enrichment of nitrogen-15, the whisper of lead or mercury. Each betrays a moment when the planet inhaled something new. One day, a team in Copenhagen compared these signals to known geological epochs and found eerie similarities between the Paleocene thermal maximum and modern human activity. 56 million years ago, Earth warmed rapidly, carbon levels spiked, ocean acidification followed, and countless species vanished. The pattern was too familiar. For a moment, the data itself felt haunted, as though the planet were recalling a previous fever. Was it purely natural? Almost certainly. And yet the resemblance was enough to raise the question anew. If such an event happened again and again, how could we tell the difference between nature and civilization? Far from Antarctica, other scientists listen in different ways. Deep sea cores, drawn from the Mariana Trench and the Atlantic abyssal plains, contain sediments untouched for tens of millions of years. Inside these sediments, isotopic ratios and trace metals whisper stories of vanished climates. Some layers show inexplicable spikes in platinum group elements, odd distributions of uranium and technetium, or faint residues of synthetic organics. Most of these findings find ordinary explanations. Some do not. Each anomaly becomes a mystery, not proof, but a reminder of how much of Earth's memory lies unread. Geologists speak of the planet as a lithic recording system, stone as magnetic tape, overwritten by tectonics, erosion, and time. To hear anything within it requires not just instruments, but patience bordering on reverence. And now, for the first time, this listening extends beyond Earth itself. Through the eyes of the James Webb Space Telescope, the Gaia Observatory, and the planned LOVOIR and HABEX missions, scientists have begun to analyze the light of distant worlds, searching for the same signatures that define our own industrial age. The method is delicate. As a planet passes before its star, a fraction of light filters through its atmosphere. By splitting that light into spectra, researchers can detect traces of oxygen, methane, ozone, even chlorofluorocarbons, molecules that, on Earth, can only exist through industry. It is the science of exoarchaeology, a search for civilizations, by their chemistry rather than their ruins. If we can recognize the fingerprints of technology light years away, perhaps we can recognize them in our own geological past. The same tools that might detect a vanished alien civilization could, paradoxically, confirm or deny the memory of one beneath our feet. Planetary scientists now think of Earth as a training ground, a reference model for what life and intelligence do to a world. They study how our industry alters cloud, albedo, spectral signatures, and heat distribution. They model how, over time, these changes fossilize into climate anomalies, mineral transformations, and isotopic echoes. Earth becomes a prototype, not merely a home, but an experiment in planetary self. One researcher described it poetically. Every planet with life eventually writes an autobiography, but the ink fades and the text erodes. Our task is to learn how to read what remains. This is the new frontier of science, not to conquer, but to remember, to see in the hum of data not just numbers, but the faint pulse of time itself. The Gaia satellite, mapping the motions of over 1 billion stars, is also mapping our sense of scale. Each precise coordinate helps contextualize Earth within the galactic record, a single rock among countless others, each with its own story written in light. In that vast perspective, our anxieties about extinction and remembrance take on cosmic proportion. If every world that gives birth to intelligence also forgets it, then perhaps the silence of the universe is not emptiness, but repetition, the quiet between verses of a repeating song. Even now, new missions are being designed not to look outward, but downward. Planetary introspection, as some call it. Autonomous underwater vehicles sample ancient sediments. Drones scan desert strata with spectral imaging. Quantum sensors detect atomic shifts invisible to the human eye. Each discovery deepens the paradox. The more we learn, the more we realize how easily we might disappear. And yet, beneath the melancholy lies a strange hope. For the first time in cosmic history, a civilization is learning to hear itself, to trace its own reflection in the chemistry of air and stone. This act of listening is, in itself, resistance against oblivion. To study the planet's memory is to extend our own. Perhaps that is the true purpose of science, not merely to explain, but to remember, to ensure that, even if every monument falls, some echo of thought remains embedded in the matter of the world. When future beings, human, alien, or something else, study the strata of a long-forgotten Earth, they may find in the rocks a peculiar anomaly, a brief, shimmering signal, carbon-rich, synthetic, radioactive, like a heartbeat frozen in time. And from that anomaly, they might infer that once this planet awoke, it built telescopes and theories, cities and questions. It learned to look back into its own depths. It learned to listen to the stones. And in that listening, It became part of the universe's memory, not through survival, but through awareness. Science, at last, had become the planet's way of remembering itself. Asterisk, there is a silence deeper than absence, the silence of forgetting. It does not come suddenly, like a catastrophe. It arrives softly, grain by grain, as wind and water erase what once believed itself immortal. This is the fate not only of empires, but of planets. For even the earth forgets. Every civilization imagines itself eternal. Every language carries within it the illusion of permanence. But beneath that illusion, a quiet truth endures. Time does not preserve it, erases. Continents shift, mountains rise and crumble, oceans devour coastlines. The archive of the world is rewritten endlessly, each new age pressing its weight upon the old. And so, as humanity builds its towers of glass and steel, its archives of code and memory, it writes upon a medium that does not keep. Stone is temporary. Data is temporary. Even atoms decay. The earth endures, but its surface, its stories, do not. Somewhere in the mantle, crushed between layers of ancient seabed, lie the molecular ghosts of ages we will never know. Entire continents have vanished there. Entire languages may have dissolved in the chemical tides of deep time. What we call prehistory may simply be what the planet could no longer remember. To live on such a world is to dwell inside a grand act of amnesia, a sphere that forgets faster than it creates. And yet, within this forgetting, consciousness arose. For a brief moment in geological eternity, matter learned to think, to name itself, to look back. It became aware of its own transience. That awareness, fragile, luminous, is what separates a stone from a civilization. But even awareness cannot stop entropy. The carbon bonds of thought, like the fossils of bone, will one day unweave. Carl Sagan once wrote that we are a way for the cosmos to know itself. But perhaps he did not go far enough. Perhaps we are also a way for the cosmos to remember itself briefly. And when that memory fades, the knowing goes with it. The universe forgets as completely as the Earth does. Galaxies dissolve into radiation. Black holes evaporate. Even the cosmic background, the faint echo of the beginning, will thin into silence. The final truth of existence may not be destruction, but forgetting. Humanity stands within this vanishing act, suspended between memory and oblivion. We measure our lives in years, our species in millennia, our planet in billions of years. But these numbers offer no comfort. They only magnify the scale of loss. For all our science, art, and architecture, the timeline remains merciless. In 10,000 years, the cities will crumble, iron will rust, glass will fog. In 1 million mountain ranges will shift, swallowing their remains. In 100 million, the continents will rearrange, and the strata will close over our memory like a wound healing. If another species were to rise in that far future, intelligent, curious, equipped with instruments finer than our own, they might find, at best, a chemical whisper, a layer of strange isotopes, a faint excess of carbon, a thin band of plastic residue, a signal but without a sender, the ghost of a civilization without a name. And yet, perhaps that is not tragedy, but truth. For memory was never meant to be infinite. Even in human minds, recollection fades, reshaped by time and emotion. What remains is not accuracy, but meaning. The same may be true of the planet and of the cosmos itself. What survives of any age is not its monuments, but the resonance it leaves behind. A feeling, a pattern, a possibility. In this way, the earth itself becomes a metaphor for the mind. Both record, both forget, both are shaped by pressure and erosion. Each new generation overwrites the last, until only the faintest impressions remain. And yet, those impressions shape everything that follows. Even what is lost exerts a gravity of its own. There is a strange beauty in this impermanence, the idea that the universe, in all its vastness, keeps no permanent archive. Every world, every star, every thought becomes part of a cycle of appearance and erasure. Perhaps eternity does not lie in lasting, but in recurring. Perhaps every civilization is a wave, rising, shining, breaking, then merging again with the sea. The physicists call it entropy. The poets call it time. But in the quiet between them lies something sacred, the realization that being forgotten does not mean one was meaningless. A spark may vanish, but the light it cast ripples outward, unseen, carried in the particles of all that comes after. If there were others before us, civilizations erased by the same clock now ticking beneath our feet, their silence may not be warning, but reflection. Their absence does not condemn us. It reveals us. For to wonder about the forgotten is to stand within their lineage, to feel the pulse of continuity beneath the dust. We are their afterthoughts, as others may one day be ours. The earth remembers nothing in words, but everything in consequence. Each breath of carbon we exhale, each flicker of light we ignite, alters the planet's chemistry in ways that will persist long after memory fails. We will be gone, but our influence, subtle, molecular, spectral, will remain folded into the crust, like a faint echo of intent. Perhaps that is enough. In the final imagining, the camera drifts outward through layers of soil and stone, each shimmering like pages of an immense unfinished book. Fossils, isotopes, sediments, each one a syllable of a language the planet once spoke. The pages blur, merge, and fade until only the outline of the earth remains silent, luminous, turning slowly in the dark. There is no monument here, no record, only the unbroken rhythm of forgetting and the faint, impossible memory of what once dared to remember itself. Somewhere deep in the strata of time, the last trace of civilization glimmers for an instant, a chemical breath, a pattern in stone, and then dissolves into the long silence that follows all things. The earth closes its book, and the universe forgets the name it once gave itself.